Thank you. So I'm going to talk about libraries today. So nowadays, a practical programming language must come with many libraries. Without a library, that language might be nice, but it's useless. So suppose you are developing a new programming language. In that case, if you want to make your language pragmatic, you have to hire engineers to implement libraries, many libraries if you have money, or if you run a big, large enterprise company. Or you have to implement foreign function interface to borrow libraries written in existing languages. So the FFI is a topic of this talk. So what is a foreign function interface? It is a mechanism to call a function written in a different language, usually the C language. So many programming languages have FFI to access C libraries. So this has been good enough because before the libraries are C libraries only. We can ignore other libraries written in other languages. Well, in practice. So FFI uses a function as the abstraction for accessing libraries. So that's the key. That's why it's called FFI, function interface. So this is good. This is fine because C libraries are basically collections of functions. So it's very natural to enable to call a function written in C. So Ruby. Ruby is not a new language. It has a very, I don't know, it's 30 years, 20 years, more, 30 years old. And it's a kind of still dominant language for web applications domain. So Ruby has the FFI to borrow C libraries, like regular expressions and sockets and TCP IPs and everything. But nowadays, people start saying, where is my NumPy in Ruby? Where is my matplotlib in Ruby? PyTorch, maybe RubyTorch, but something like that. TensorFlows, Ruby TensorFlows. So people start saying that. The reason is now the Python is one of the major sources of useful libraries, practical libraries. Many useful libraries are written in Python these days. For machine learning and data science and more and more. Even in the web application domain, there are lots of nice Python frameworks and interfaces. So, well, I hope there is no Ruby big fan here in the room. But my observation is that the users are leaving Ruby because they wanted to use the Python libraries. For instance, actually, I'm teaching kind of programming course for novice students. And recently, we switched the language from Ruby to Python because Ruby was invented by the kind of Japanese guy. So we want to keep that class to use Ruby, but there's lots of kind of political pressure to use Python. So that's kind of sad. OK, some smart guy implemented PyCall for Ruby. PyCall is a library to call, it's an original PyCall. It was invented for Julia to call a Python method from Julia. So one guy implemented the same thing for Ruby. So now we have a FFI from Ruby to Python. So Ruby can call a Python method. So look at this sample code. So it's pretty similar. This is a Ruby code, and this is a Python code. This one uses a PyCall. So the only difference is how to import modules. So in Ruby, you have to say import module pyplib.pyplot, and the rest of the things the same. Exactly the same. Great. Nothing to do for research. No. There are pitfalls. First of all, the syntax of constructor call is different between Ruby and Python. So this is a Python code. Well, suppose we wanted to use a deck in collections module. You write this. But in Ruby, look at it. Can you see this? There's a small dot here. Because deck is a class name in Ruby. But this one has to be a constructor call. So to distinguish, Ruby users have to place dot here, or explicitly they have to write dict.new because this is an object creation in Ruby. Well, it's very minor thing, but very annoying. Oops. Second example, keyword argument. In Python, keyword argument is written like this: LW equal 5. Keyword the argument named LW is 5. In Ruby, you have to say colon. It's meaning the same, LW colon 5. But problem is, in Ruby, you can also write LW equal 5. What happens? Well, this is assignment in Ruby. So the 5 is assigned to LW, which is a local variable. Maybe LW variable, local variable is created here at this time because the Ruby is dynamically bound language. That's, I should say, bad. So it's very difficult to find before running the code. This is the final one. Dictionary. This is a piece of code I took from TensorFlow tutorial. TensorFlow, biggest one is the big thing. Well, it's getting minor, but still important. So in Python, you have to say, to make a dictionary, you have to say x data colon 2.0. X data refers to an object produced by a TensorFlow library. So it's a deep embedding. In Ruby, you have to say x data row 2.0. So you can't say, you have to carefully change the colon to a row when you port Python code to Ruby. Problem is, you can, because Ruby has a very, very flexible syntax, you can also write x data colon in Ruby. And this perfectly runs. This doesn't produce any syntax error. It runs. But the semantics is slightly different because in Ruby, x data column means a label. So this is the result in sort of a string. And this produces a kind of dictionary mapping from a string x data to 2.0, which is different from this dictionary because this dictionary maps a TensorFlow kind of AST object to 2.0. So it doesn't work. So that's a problem. Question. Don't you make such a silly mistake? Maybe you say, no, you guys are very good, talented programmers, so never make this kind of mistakes. But these are real mistakes. I found these examples from in the blog entries. Unfortunately, these are written in Japanese, but trust me, these are. they complain, they made these mistakes and spend a kind of day or I don't think a week, but a few hours. So the reason is Ruby users use Python libraries. So when they use Python library, they tend to copy and paste sample code they found in the library tutorial, which is written for Python users, not Ruby PyCall users. And then try to avoid the pitfalls. Can they avoid? This is a very psychological thing, but my observation is that the sample code includes not only the function name, which function should be called to do this thing, but also the arguments, because Python provides very rich constructs to make a data set, and which is one of the power of Python. So here in Python, the sample code means both function name and how to construct an argument in a very shorthand, in shorthand. So my claim is that the functions is sort of a wrong abstraction. Well, if you want to borrow C libraries, function call is a perfect abstraction to borrow the libraries in C. But in Python, function call or method call is not enough. This is not because Ruby's syntax is very similar to Python's syntax. I think Ruby, because Ruby users expect arguments are Python code, part of the Python code. I mean, the sample, because they copy and paste from the sample tutorial. So carefully look at this. This looks like a Python function call, but if you carefully look at that, this, first of all, we have to do a kind of method dispatch here. Which session, we have to resolve which session is. This resolution is done in Ruby, not in Python. So that's one of the sources of the problem, pitfall. Same for this. Because I copied this whole expression, whole statement from a Python tutorial. So I suppose this is also Python code. But yes, because argument is not a part of the function call. So this argument expression is evaluated in Ruby, in the context of Ruby. So, and result in a symbol. So here's our idea. It's very simple. Actually, one of the fun part of my talk ends here. The rest of the thing is sort of kind of straightforward, But please listen. So our idea is very straightforward. Well, if you have an experience of Lisp. So idea is let's deal with this expression as Python code, although it's in Ruby, and syntactically this is a Ruby code. Well, that's for Ruby novice people, audience. This curly brace makes a kind of block argument. It's a lambda, and it's automatically passed to method Ruby run Python method. Well, this is not only unique in Ruby. If you are a Scala guy, this notation is very, very popular in Scala. I think you guys are like a Scala, so I hope this thing is not weird Ruby only thing. So I say this has some sort of genericity. But for using the standard Ruby toolchain, because I don't have a resource to develop a whole toolchain for my extended language, I say we should use syntax, Ruby syntax. So in this sense, this part is the code written in an embedded DSL in Ruby. So you see this, this is a DSL, because Ruby doesn't have a with statement, but Python has a with statement. So to write with statement in this block, we have to define some sort of a DSL, which uses a Ruby syntax and looks very similar to with statement in Python, but still syntactically it's a Ruby code. So this one is interpreted as this. This is a call to with method, and coming with one argument, which is a dictionary, open to F, and also the lambda expression representing a block. So with is basically a fake statement. It's a method called to with, and the dictionary is an argument. But from a syntactical viewpoint, it's still Ruby code. And I developed some framework to extract an AST to AST for this, and convert to Python code and run the Python code. So if you know the Lisp macros, it's pretty straightforward to implement this. So to this approach, by this approach, you can easily use a matplotlib library written in Python from Ruby. So the difference is only red part. This is a Ruby code, and this is a Python code. Look at this. The difference is only a few lines, and because this is a DSL. And so I can define the semantics by myself. I don't have to follow any Ruby semantics or Python semantics. So I defined a semantics in which labels, free variables are bound to Ruby world. So when you execute this, these values are automatically passed to Python interpreter. It's make a copy, and the value is passed. So there is no reference passing, but because it depends on the PyCall. I heavily use PyCall. So, how to implement? Ruby doesn't support macros. And the guy who invented Ruby officially said that he hates macros. So no hope to introduce macros in Ruby, or so far. Maybe other guys successfully persuaded him to change his mind, but in future. So I implemented a kind of different system, which is, this one is called Yadorigi. It's a small framework, a light Ruby framework. It allows you to reify an AST of the given lambda expression. So it's a reflection library. I'm a reflection guy, so I prefer this approach. So if you make a lambda expression here, this is a syntax in Ruby, and pass it to reify method provided by my library, it automatically finds the source code of this and constructs an abstract syntax tree and returns it. So it's like a macro, but it's not macro. It's a reflection. So implementation is quite straightforward. You can define run Python method like this. First, take a block, which is a lambda expression following the method call. Make an AST, abstract syntax tree, and generate Python source code from this, and called pycall eval, which takes a string code, source code, and execute it on Python interpreter. So this is very similar to macro implementation. But if you use a macro, you have to kind of recursive macro expansion. So it's a little bit complicated, and many people pointed out that that approach has lots of other pitfalls to implementation. So I hope this way is more straightforward. This is not really advantage. Well, I prepared this slide on an airplane, so I failed to choose an appropriate one. But this slide is basically saying that our way, because a lambda expression is a first-class object, so it's very easy to define a kind of convenient function by the users of the run Python library, like logging. It's because it takes this is a normal Ruby function which takes a lambda argument, a lambda expression, and prints some message, and then calls run Python again. Because block is just a value, ordinary Ruby value, so you can reuse that. So you can do these macros, yes, by nested expansion, but again, I hope this one is more straightforward and easy to avoid errors. The reviewers told me that this work only will be applicable to Ruby and Python because these two languages are very similar. So this approach might be effective only pair of languages which have the similar syntax. But my claim is no, not only a similar language like Python. So this is an example to access C code, C library. I also implement this one on top of a Yadorigi framework. So in C, this is a kind of definition of a Fibonacci. So this code is also DSL embedded in Ruby. And if you run this, oh, by the way, this function call refers to this Ruby function. So the system automatically recognizes this is also part of the DSL. So it also extracts this AST of this function. So the problem, an issue is in case of C, we have to define the types, static types. And the question is how to define. But again, this is DSL. I can freely design my DSL, although we have to use that Ruby syntax. So look at this. I discovered this. I think this is a nice notation. It's a ban integer. In Ruby, integer is a kind of class object, and ban it's a kind of negation. But so when you evaluate in Ruby, this returns false, but now, or I don't know. But it's still, this is DSL. So this function translate that into a regular C type declaration. my last slide. From the implementation viewpoint, I think the one of the best thing of my Yadorigi framework is that it provides a syntax checker. Because in this approach, we reuse Ruby syntax. So and Ruby has a very flexible syntax. So potentially generated abstract syntax tree is very complicated. And it's very hard to deal with that complex AST to generate right code. Maybe you ignore most of Ruby syntax, but then we have to produce some error messages in practice. But it's very, very messy. So this live framework provides a syntax checker. So this is a DSL. It provides some DSL implemented by the same framework itself. And this is kind of funny expressions, but I think it looks like a BNF. And Yadorigi takes this syntax definition and checks a given AST abstract syntax tree matches this syntax. So because we don't have to do parsing, because it's already parsed, but we have to say this fits our grammar or not anyway. And if it doesn't fit the grammar, produce the syntax error and ignore the rest of the things. So it makes it easy to implement kind of Python bridge or C bridge and other Julia bridge. Thank you. This is a summary. I presented a foreign language interface by code migration. It's not a foreign function interface. It's a language interface now because I don't use a function. And I also presented our framework to implement this idea, which is Yadorigi for Ruby. That's it. Thank you very much. Just advertisement. We are doing lots of DSL work, and another our DSL talk will be shown on Thursday.
We have time for a few questions while the next speaker sets his laptop up.
Yeah, please. Thank you very much for the talk. Would it be simpler to just embed the Python interpreter directly into Ruby, and then you run Python?
Then we have to modify the Ruby VM. I don't want to do that. I want to implement kind of regular library. And
because Ruby has foreign function interface for C, right?
Yeah.
So C
yes,
Python
actually,
is written in C.
PyCall is doing that kind of thing.
Okay.
So, but my point is that the interface is not good, and foreign function interface, the function is not a good abstraction. That's my point. So, technically speaking, Python interpreter is already embedded, included in the Ruby environment. Yeah, thank you.